Hello, Algebra 2. This would be the radical expression review. This was the homework that you guys had on the previous night, and I'm going to go over several of these questions just so that you guys can be assured of how to deal with today's test. If you guys have certain questions in mind, I'm sure that you can ask, just with each other. You guys can just ask some questions. However, um, any questions that's directed to me, I'm not going to give you guys an answer, but you guys can try to do your best in sending me an email during those times. It's due 6 p.m. today. So you guys have several hours. Don't worry, it's not going to be so much of a big deal. It's not going to be that difficult. I understand that this radical expression review, this is actually a lot of work, but the reason why I gave you so much question in such a short little amount of time was because you guys had 3-4 days to complete it. Now, I already sent you the comment saying that if you guys even turn it on Wednesday, it's okay for me. I understand this was a lot of questions, but these two particular pages in the beginning, these should have been done, in the first day. It's very, very simple because all you have to do is, for example, let's just start from like number one, for example. This right each expression in a radical form, all you have to do is just move this 4 in the front and say fourth root of 5n. It's just that simple. This, move the denominator always to the front, so it's second root of n to the cubed. That's just simply square root of n cubed, and you can just leave it as that, okay? Something like this, it's going to be the same as number one. So 4 brought to the front would be fourth root of 5x in parentheses to the 7th power. I can't emphasize how important it is that you guys put the parentheses down because it shows us that that particular entire 5x is going to be to the 7th power. There's a major difference between this one and something like this, for example. This 7th power only applies to the x, whereas this 7th power applies to this whole thing. So that's why you want to make sure that parentheses is always there for you guys to have. So I'm just going to skip all of these guys and I'm going to go right into this, in which it expresses each of these in a radical format. And also to simplify, this is actually one of the more important ones. And then we're going to go over several questions in the going over how to solve radical expressions. So write each expression in radical form, just like how we have been dealing with before. This is fifth root come to the front, and it's m cubed. And this is fourth root come to the front, so it's fourth root 10r raised to the power of negative 3. Now, whenever you have a negative exponent, you guys do not want to leave it in the negative exponent format. So negative exponent, guys, you guys always must remember that it's just simply 1 over. So this would be fourth root of 1 over 10r to the power of 3. The reason why the negative exponent is because we talked about this in the past. X squared is x times x. X to the first power is x. X to the 0th power is 1. Anything to the 0th power, guys, is 1. Do not forget that, because whatever's happening from the previous, you're always consistently dividing by x. So when you're talking about x to the negative first power, you're going to be doing the same thing. So what is 1 divided by x? It's 1 over x. What about x to the negative second power? Well, you divide by divide by x once again, so this becomes 1 over x squared. I know this is kind of coinciding, so I'm just going to take that and just like move it over. Okay, so that will be your notes for the negative exponent right there. Okay, so don't forget how to deal with the negative exponent. You just simply have to do 1 over and then put whatever that's left without the exponent, without the negative sign, right as the denominator. So, for example, if I were to give you 7 to the power of negative 3 over 4, that's just 1 over 7 to the 3 over 4. Just put the entire thing in the denominator. The negative sign is taken care of by doing this 1 over, and that's it. Write each expression in the exponential format. I'm going to do 5 and then let's say 6. 5 would be, well, take a look at this. It's 1 over that, right? So I'm going to do, that is taken care of by putting a negative sign in the exponent, and the exponent turns out to be a 3. And then the parentheses is square root of a 6x. But if I want to put in an exponential format, I want to make sure that I get rid of this radical symbol too. So this radical symbol, I can rewrite it as 6x to the power of 1 half, okay? This thing becomes this thing right here, and then you have to put negative 3 right next to it. So my final answer then therefore should become, in parentheses, do not forget about the parentheses, like I said, it's negative 3 over 2. That should be the answer. Number 6 is pretty simple. It's v to the power of 1/2 because every square root we should know that it just turns into 1/2 power. Just for the sake of doing the problem, I'll show you how to do number 7. Number 7 should be 4th root of n to the power of 7, but make sure you take care of this 1 over by putting a negative sign in front of the 7. Then bring the 4 outside, so it should be n to the power of negative 7 over 4. Okay? All right, evaluating. Evaluating simply means to get the number. So your answer should not to be simplifying it, write each expression in an exponential format. You want to get that number. So to do these problems, you can use the calculator to help you solve for these. So you can do 8 caret 2 slash 3, and you guys should be ending up with a 4. Now, how do you get that? 8 is simply same as 2 to the power of 3. So I'm replacing 8 with the power of 2 over 3, and you have to put 2/3 right next to it because that's the exponent next to it, and the 3's will cancel out, so you get 2 squared, which ends up being 4. And so the calculator should also give you a 4 after that. Number 11 here, you can simply take 4 and make it 2 squared, and that's 3 over 2 power right next to it. And so 2's will cancel, that's 2 to the 3rd power because that's 2 to the power of 3, and that should give you 8 as your final answer. Also type that in your calculator, I guarantee you will get an 8. Okay? Now, for some of these questions that you guys might be dealing with, yes, I understand that these were just a little bit above extra, but here's what's going to happen. You guys are just simply going to apply your knowledge of how to deal with the exponents when they're being multiplied like this, for example, on question number 13, or when they're being divided, for example, question 17. Okay, so I'm gonna show you guys how to do these 4 problems, and then if you guys want to know, I'll take on some of these challenging questions. So for example, let's say 31. Okay, just to show you guys how to deal with these problems, because 31 is a composition of both multiplying and dividing at the same time. Okay, so I'll go over those 5 questions with you, and that should be plenty to how to do these questions. Okay, so first, number 13. You're going to combine like terms. Okay, and so how do we do that? Well, in order to do so, you're going to have to take a look at the x's together and the y's together. And remember, guys, when you're dealing with the exponents, y to the a power times y to the b power, that simply is y to the a plus b. You add the exponents when it's being multiplied, and when you're dividing them like this, you're going to have to subtract the exponents. This is really the main rule that you have to apply for all of these questions. And the last one is, let's say y to the a power raised to the b power, just like how, for example, number 16 has, where you have a parentheses around raised to the b power. Then that's when you guys would multiply the exponents together. So here, when you're talking about x times x right here, you guys always must remember that you guys are going to add the exponents. Now, what is the exponent for this x? Is that it's x to the 1st power. So when you're adding just the x's, it should be x to the power 1/3 times x to the 1st power, and then the y's you must combine together, so y times y to 3 over 2. Now here, you're going to add the exponents like I said. But in order to add the 1 with the 1/3, 1 over 3 plus 1, you must convert this 1 here into 3 over 3, which we call a common denominator. So then that would give me 4 over 3. So my final answer for just the x's here would give me x to the power of 4 over 3. That's the result of combining these 2 blue boxes together. Now for the y's, it says y to the 1st power. You're going to do the same thing. The 1st power plus 3 over 2, so 1 plus 3 over 2 here, would give me 2 over 2 plus 3 over 2, because that's what you're going to get when you transform the 1 into a common denominator of a 2. And so therefore you're going to get 5 over 2. So your final answer will be y to the power of 5 over 2. And this is how you would combine them or simplify them into one singular rational exponent form. Okay, so you add the exponents. What about for question like 14? Well, 14 has a 4 in the front. What do we do with the 4? Nothing. You just put the 4 in front of it. Well, what if this one had a 2 in the front, like this? That's when you would multiply 4 into 2, and you get an 8. But since we don't have that, I'm just going to erase this and just leave it as a 4 for now. And the V's here is where you guys are actually going to compute the, I'm going to put that in a quotation mark, compute the actual math portion of this question. So like before, you're going to add the exponent. So v 2/3 plus -1, right? You add the exponents. Well, how do we add the exponents again? We need to have the common denominator. 2/3 minus 3/3 gives me -1/3. So therefore, my final answer for v should be v to the power 1/3. If I want to have only positive exponents like the question said, what we want to do is we want to transform this, just the v. Now remember, there's a difference between, I have to just write so many things on the side here. There's a 4v to the power 1/3 and then parentheses 4v to the power 1/3. There's a major difference between these two. The answer for this would be, this would be turned into 1 over v 1/3 and the 4 would be just multiplied to it. This here would mean this entire thing would go in the denominator as such, and you put 1 over the whole thing. Now, what is the major difference? Well, the first one has 4 over 1 power, 4 over 1. This one has 1 over 4. That is really, really huge. So the way that you write the answer for this one would be 4 over v 1/3. Notice how 4 is at the top because you're multiplying by 4. And for the answer for this one would be 1 over 4v to the power 1/3, which means you're basically multiplying by what we call 1 over 4. So the answer to this question here, if you go to the top, I would write 4 over v to the power 1/3. That should be the answer for number 14. Number 16, guys, believe it or not, it's just simply going to be 1. Now, the reason why I'm sharing with you guys number 16 is because I want you guys to know how the 0 power impacts to both x's and the y's. What did we establish in this equation is that you will multiply the exponents together when they're outside the parentheses. So for example, number 16, it's getting a little hectic out here because I need to write down everything into just one note. But I have to write x to the power of 5/3 raised to the power of 0 because this 0 gets distributed to both here and here. Now, there's a difference between this, I have to do this one more time, x to the power of 4/3, y to the power of, what was it again, -2, to the power of 0 like this, and there's difference between that and this, plus y -2 to the 0 power. I've seen so many kids do the 0 power to apply to both here and here when they're being added. This is completely not acceptable because remember when you guys were doing this? This means literally to take x plus y and multiply by x plus y. Not distribute the 2 to both here and here and get x squared plus y squared. I know that some of you guys have done that in the past, but you actually have to FOIL it. Those two are completely two different problems. This one, for example, they're being multiplied in the middle. Therefore, you can just simply take the exponent and just multiply it, distribute it, and get x to the 0 power, y to the 0 power, because 0 times anything should just give you a 0, right? Well, we also established that anything to the 0 power is 1, anything to the 0 power is 1, so therefore 1 times 1 is simply just 1. So the answer to question number 16 should just be a 1. Okay, next, question number 17 and question number 18. These are the last ones that I'm going to do. Question number 17 and 18, you guys, oh, actually not the last one because we have one more, 31 to do, right? 17 and 18, they're both being divided, right? Instead of multiplying, we're going to divide those fractions together. And you guys are going to be applying this rule, where when we're multiplying, please remember that you're going to subtract the exponents together. So what do we do? Well, first, for number 17, I see that it's a squared b to the 0 power over 3a to the 4th power. Notice how this b to the 0 power has no impact to the question whatsoever because this is simply just 1. So I can rewrite this expression and say a squared over 3a to the 4th power. Okay? Now, when we're doing these problems, please note that you guys can take a look at how you can if it's a regular numbers, you can cancel them out like this. So this would just give you a 1 and this would just give you a 2. The reason why that is because, well, if I were to rewrite it in this format, a times a, 3 times a times a times a times a, because that's what it means to have a 4th power. Notice how 2 of these will cancel out and there should be nothing left, but that doesn't mean that it's a 0, it means it's a 1 in there because a over a is not 0, it's 1. A over a is not 0, it's 1, so 1 times 1 is just simply 1. And 2 of the a's is in the denominator, so the way to rewrite this question is 1 over 3a squared. another way to do it is, imagine if you were to just take the a's together. A squared divided by a to the fourth power. We established how you're going to do the 2 minus 4, how we're going to subtract the exponents like that. Well, that is simply a to the negative second power. Well, negative second power, we can always rewrite it as 1 over whatever's left, which is a squared. And therefore, that's where this comes from. And the over 3 just simply stays as it is. So the 3 stays in the denominator, it stays right down here, and nothing changes. Okay? All right, so for question number 18, we have a fractional exponents, and so this might get a little tricky, but just remember what we're supposed to do for these questions is that you're simply going to combine them and subtract the exponents together. So here, the very first thing you guys need to recognize is that the 2's will just simply cancel each other out because 2 over 2 is just going to give you 1. And then let's just take a look at the x's together right here. The x's say x to the power 1/2 divided by x to the power of 4 over 3. When we're dividing those together, what happens to the exponents? They always subtract. So here, I can combine them into one singular x and say it's 1/2 minus 4 over 3. Well, I have another question here where I'm subtracting the exponents. Whenever I'm subtracting fractions. Whenever you're adding fractions or subtracting fractions, you always want to have what we call a common denominator. So to have a common denominator, you have to have 1/2, 4 over 3. It seems like 6 is the best bet. So multiply 3 over 3 here, multiply by 2 over 2 here. Well, where did those numbers come from, Mr. Kim? Well, it gives me 6 down here. It gives me 6 down here. This is not something that I want to go over in detail. You guys should already know how to do that. So that's simply going to become 3 over 6 minus 8 over 6 gives me negative 5 over 6. And so what my final answer going to be for 18 then is, I know that it's a little hectic, so I'm just going to, let me just write it down here. Ooh. I'm just going to erase all of this part. So 18 here, I'm going to write down as x to the negative, I think it was 5 over 6. That was my answer for the x's. Now for the y's, what I'm going to do is I'm going to take the y to the 1 over 3 and y to negative 7 over 4, and I'm going to subtract them. But see what happens is, if I subtract negative 7 over 4, notice how there's a double negative sign here. So what happens to the double negatives? It actually makes it into a positive. So I'm going to add the exponents together, even though it's a division sign. I know that kind of might be confusing, but we're subtracting a negative symbol. So just like how, as if you would subtract a negative number, it means you're going to add them. So 1 over 3 plus 7 over 4, make sure you understand that the common denominator will be 12. So 4 over 4 here and 3 over 3 here. Multiplying by what we call form of 1, right? That's 4 over 12 because it's 4 times 1 times 4 times 3 plus 7 times 3, which is 21. 4 times 3, which is 12, gives me 25 over 12 in total. So my final answer for this question would be x to the power of negative 5 over 6 times y to the power of 25 over 12. But since we don't want to have any negative exponent, just put 1 over. So the y to 25 over 12 power will be staying at the top. And this right here will stay in the bottom, x to the power of 5 over 6. Because that's simply saying 1 over x to the power of 5 over 6 times y 25 over 12 over 1, if you want to think of it that way. This becomes this becomes that. There we go. Okay? Now, applying the same rule here, you guys can try to doing this on your own, but I'm going to go through with this really quickly. This negative exponent applies to all of these three, so I get x to the power of 4 over 3, y to the power of positive 4 over 3, y to the power of negative 1, over x power of 1 over 3, y to the power of negative 2. Then, if I combine these two together, I should get y to the power of 2 over 3, because you have to add the exponents. Put these two together, I believe what you're going to get is y to the power of 4 over 3, positive. Then you're going to subtract these two and get x to the power of 3 over 3, which is simply 1. So you get x to the power of 1, y to the power of 4 over 3, and that's your final answer. Okay? I know I went through that really quickly. If you have any questions about that, please let me know. Okay, so this is the last part of the video. I'm going to show you guys how to do questions, maybe, for example, number 3, number 1, number 3, and let's say I would like to show you guys something like, well, I'm going to revise maybe number 4 just to show you guys what to do. For all of these questions, you guys are not going to have a quadratic for the test, just like how I've shown you in the previous video. But for example, for number 1, your very first step should always be to get rid of this radical sign once it's by itself. Key word here is by itself. So you would, ooh, sorry, I don't know what happened there. Let's see. Okay, here we go. Okay, so here what I'm going to do is I'm going to square both sides like this, and square both, like square that side also, and then what you're going to get is x plus 1 is equal to 16. Subtract 1 on both sides, and you get x is equal to 15 as your final answer. Okay, now let's say I modify this first question just a little bit and say square root of x plus 1 minus 4 is equal to 4. So let's say you got a question like that. What are you supposed to do? Remember that all of these questions, you want to isolate. Your main idea is to isolate the radical. When I say isolate, I mean just get the radical symbol by itself. So here I have the radical sign and I want that by itself, but it has this unwanted guest a negative 4. So what's my first step? Is to get rid of this to the other side. How do I get rid of negative 4 to the other side? You add the 4. And what you're going to get is square root of x plus 1 is equal to 8, and then it's going to be the exact same process as how you would do number 1. You would square both sides and get square here, and get 64. Subtract 1 on both sides and get x is equal to 63. Okay? Now, even if you have a negative number like this, square root of p minus 4 is equal to negative 5, your first step should always be the same, where you would square both sides like this. P minus 4 is equal to 25, add the 4, and get p is equal to 29. Your final question that I'm going to share with you guys, that one's a quadratic, but I do not believe this shows up on the test. So you guys can just take a look at a reference guide and help have this figured out for your for reference guide to how to do these problems at the end. But at the end of the day, it's pretty much going to be quadratic here, and then you're going to have to solve for what we call extraneous solution. So you will have to square it, both sides, and then what you're going to get is 2 minus x is equal to x squared minus 4x plus 4. Since it's quadratic, move everything to one side and set it equal to 0. X squared minus 3x plus 2. Well, how did I get that? Subtract 2, add the x, subtract the 2. And once you do that, you should be able to get that. Please factor accordingly, get the values, and remember, your last step is to always to just simply plug it back in and get your final result. Okay? For questions like these, for number 7, I just remember that you might have a question like this on the test. You do not have a square root, so you don't square it, but you have what we call a fourth root. Okay? So let me rewrite that question. Fourth root of 2p plus 2 is equal to 3. So what are you going to do at this stage? Well, to get rid of this fourth root, what you have to do to both sides is that you don't square it, you raise it to the power of, right, 4 to cancel this out. So then it's simply the same step as number 1. It just, you don't square it, you do it to the 4th power. If you want to use the calculator, go ahead. 3 to the 4th power simply becomes 81, and this is simply an algebra questions from that. Okay? For question like 15, you want to square first and get s cubed. So your first job is to always get rid of the radical sign first, and then to get rid of cubic functions, you want to do the opposite of cubing. And I think I mentioned this before. To get rid of cubed, you want to do raise it to the power of the reciprocal of it, which is to the power of 1 over 3. Just like as if you would, if I gave you that x squared was a 4, you want to square root both sides to get rid of the square. Well, it's same thing as if it's a square rooting it, you're raising it to the power of 1/2 on both sides. It's simply the same process as this one. So these will cancel out. It's to simply 16 to the power of 1 over 3. And I'll accept that as an answer. This is perfectly fine. Okay, so hopefully this video helped. Let me know if you have any questions. And you have 7 questions to finish by 6 p.m. and that's going to be it for today. This is your test grade, so make sure this really make sure it counts. Hopefully this will give you a lot of you kids a grade booster. And for the next week, I'm going to share with you guys a new topic and we're going to be dwelling in that. Your grades will be due by next Friday, but we still have the potential to change it by next Sunday, which is April 5th, right before your spring break starts. Even though it doesn't really feel like a spring break because of all the coronavirus mishaps, do your best. We still have 5 days left over or 6 days in total, regular school days, including the weekends that might be giving you guys about 10-day window from now. Please shoot me an email. I know some of you guys have shoot me a lot of emails, but I haven't gotten to it. I will make sure I respond to you guys on ASAP basis and not take so much time. Anyways, thank you and have a good day.